Hey, it's Mr. McHugh with an example on coterminal angles, and to get us a better understanding of what they are, what they look like, and how to calculate them, we're going to look for two angles coterminal with 3 pi over 8. Now, you don't need a graph or to draw the angle 3 pi over 8 in order to do this, but it's helpful to see things. Helps you with a better idea of what's going on. So let's go ahead and draw an angle that would have measurement 3 pi over 8. Doesn't have to be exact, but somewhere in this range, somewhere greater than 2 pi over 8 and less than 4 pi over 8 gets us this angle. So here, if we call this angle theta, let's say, we'll just give that the name theta. We want two coterminal angles. Now let's start with a positive coterminal angle. Positive meaning we're going counterclockwise from the initial side. If we start out going counterclockwise, now we need an angle that starts and ends at the same initial and terminal sides as theta but has different angle measurements. So let's go all the way around the circle, one complete rotation, and then keep going and stop at the terminal side of theta. So what did we do? One full rotation all the way around. The origin is 360 degrees or 2 pi radians, and then we continue on past that to the end of, to the terminal side of theta. So what we've essentially done is we've taken theta, we've taken its angle measurement, and we've added one full rotation. Since we're working in radians, we'll keep working in radians, and that one full circular rotation in radians is 2 pi. So that gets us our original theta, 3 pi over 8, plus 2 pi. Now we're going to convert 2 pi into 16 pi over 8 so that they have common denominators, add them together, and 19 pi over 8 is our first coterminal angle with theta. Now if we want to keep going with positive coterminal angles, we could go more than just one rotation around. We could go 2 full rotations around, which would be 4 pi. Or we could go 3 full rotations around, which would be theta plus 6 pi. And you can see if we keep going full rotations around and stopping after those full rotations, stopping at where theta's terminal side is, then we'll have coterminal angles. And we could keep this pattern. There's an infinite number of options. So those are your options for positive coterminal angles. Now what about negative coterminal angles? Negative coterminal angles are going to start at the initial side, but we're going to go clockwise this time, and we're going to calculate that angle, which starts at the initial side, ends at the terminal side of theta, but goes in a clockwise direction. Very similar to how we got this positive coterminal angle, we're going to get the negative by subtracting 2 pi from theta. Now that's a little bit harder to see, but you can imagine if we start out at the terminal side of theta, this negative rotation is a full 360 degrees, or 2 pi radians. So if we start out at theta and then go backwards a full rotation, that's what we saw happen right here when we did this full backwards rotation. And having seen that, now the math isn't so hard. We're taking our 3 pi over 8 theta, and now we're subtracting what we've already converted previously into a common denominator, 16 pi over 8. And after the subtraction, negative 13 pi over 8 is our negative coterminal angle. If you've tried to get a negative angle and your math works out so that you don't end up with a negative answer, you've done something wrong. And then finally, just like we could add 2 full rotations to our theta, we can do the same when we're subtracting. Instead of subtracting 2 pi, we can subtract 4 pi, or we can subtract 6 pi, or any full rotation we can subtract. So again, an infinite number of negative coterminal angles.